Okay, so what if we could take this, a massive 4 GB pile of just raw data, and turn it into a living, thinking AI graph? Well, that's exactly what we're about to do. We're going to go from a bunch of disconnected files to a fully functional recommendation engine. And believe it or not, we're doing it all right here on a single laptop.
First, we really need to talk about the Excel view of the world. You know the one I'm talking about. As product people, we're kind of trained to see data in tables, right? Users go here, orders go there. We treat everything like these isolated little islands sitting in their own rigid boxes. But that's just not how the world actually works.
So really, there are two ways to see your data. There's the old way, the Excel view, with its rigid, disconnected tables. But then there's how the most advanced companies, think Netflix, see it. They use what I call the constellation view. They don't just store data, they store the relationships between the data. And suddenly, it all explodes into this spectacular, interconnected galaxy. That shift in perspective, that's the secret to building truly smart AI.
To really get my head around this, I decided, you know what, I'm going to run an experiment. Could I really take the massive 4 GB Yelp dataset and turn it into a working graph database right here on my own machine? This is our hands-on quest to see if this whole graph thing actually lives up to the hype for AI.
First things first, we've got to build our lab. And the setup, honestly, is surprisingly straightforward. We install Neo4j Desktop, spin up a new local database, add 2 really critical plugins, one for importing data and one for the AI algorithms, and then we just hit start. And boom, just like that, our empty graph brain is ready to start learning.
So after about 8 minutes of loading, all the data is in. And look, this is not some tiny data set we're playing with. We've just ingested almost 2 million users, 150,000 businesses, and nearly 7 million reviews that tie them all together. The crucial thing here is that all of that raw, messy, disconnected data is now a living, structured network inside our graph.
All right, with all the data loaded up, we are officially moving from the engineering phase to the discovery phase. We've built the structure, now it's time to see if these connections can actually talk to us and tell us something interesting.
But you know, after all that work, there's always that one big question looming. Did it actually work? I mean, is this just a huge pile of data sitting in a fancy new format? Or have we really created a truly interconnected network?
And the answer is a resounding yes. This right here, this is our hello world moment. What you're looking at is the first unbroken chain in our data. It's the visual proof that a user is correctly connected to a review, which links to a business, which belongs to a category. Our whole idea on paper is now a living, breathing reality that we can actually click through and explore. Okay, now for the main event. Let's use our brand new graph to solve a real-world problem. Where should I eat tonight? To do this, we're going to quickly prototype 3 totally different AI recommendation models and see which one gives us the best answer.
So model number 1 is content-based filtering. The best way to think of it is as the librarian. It looks at the attributes of something you liked, say you went to a taco place, and it finds you, well, more taco places. It's safe, it makes sense, but it can easily trap you in a filter bubble.
Next up, we have collaborative filtering, or as I like to call it, the friend. This model is totally different. It completely ignores the attributes and focuses on people. It goes out and finds your taste twins, other users who have similar tastes, and then it recommends what they loved. This is amazing for discovering new things, but it has a catch. It doesn't work for new users who don't have any data yet. And just look at these results. This is the magic of the friend model in action. We're getting recommendations for ribs, bagels, and Indian curry. Now, this user might never have thought to look for Indian food, but because their taste twins loved it, the engine dug up this hidden gem for them. This is exactly how you break out of that boring filter bubble. And finally, we get to the hybrid model, the expert. Honestly, this is the gold standard. It's the best of both worlds. It takes those great recommendations from your taste twins, and then it does one last check to make sure they also line up with your own personal preferences. It's the perfect balance of discovery and relevance. And here it is, the winning result from our expert model. Get this. The top recommendation is validated by 63 similar users. That is some serious social proof. But it also perfectly matches the user's favorite categories like steakhouses and seafood. So it's not just popular, it's popular with the right people, and it's personally relevant. That is the power of a hybrid engine. So, we've seen how to find great recommendations for one person, but the real power of a graph is understanding the entire network. So now we're going to zoom out and use something called graph data science to get a God's eye view of everything at once.
Yeah, let's be really clear here. Everything we've done up to this point has been at the micro level, focused on one person's experience. Now we're shifting gears completely to the macro level, to find insights that are hidden in the structure of the entire system.
So we used PageRank. Yep, the same algorithm Google famously used to rank the entire internet to find the most influential spots, not just the ones with the highest ratings. And this just illustrates the point perfectly. The winner, Oceana Grill, only has 4.0 stars. But it turns out it's the central hub of the entire network, connecting all the most important reviewers. Next, we used a different algorithm called Louvain to find hidden communities or social tribes. It doesn't look at maps or zip codes, it just looks at people's behavior. And it found that Tampa and Clearwater basically act like one big social community. But get this, it also detected a social wall between Philadelphia and its own suburbs. People there just don't mix in the same way.
So, after all that, what did we learn? Let's talk about the final verdict on this whole experiment, some of the real challenges I ran into, and what all of this means for the future of AI.
Now, I have to be honest, this journey wasn't perfectly smooth. I hit a wall almost right away with security errors and memory crashes, as you can probably tell from these screenshots. The only way forward was to dive into the configuration files and manually tweak the defaults. It's just a great reminder that with these powerful tools, sometimes you gotta get your hands dirty. So the big question, was it worth it? And my answer is an absolute, unqualified yes. For any problem that's fundamentally about relationships, like recommendations, fraud, social networks, you name it, graphs are just infinitely better than old-school tables. The trade-off? Well, there's a steeper learning curve. You have to be willing to shift your brain to thinking connections, not just in rows and columns.
And this all points to what's coming next. The huge new frontier is combining graphs with large language models in something called GraphRag. Just imagine giving an LLM, like GPT-4, a structured, factual brain, like the one we just built. This is how you fight AI hallucinations, because you force the model to base its answers on real, verifiable facts from the graph instead of just making stuff up.
We've seen how transforming raw data into a graph unlocks these incredible new powers. It lets you move from just storing information to truly understanding it. So really, the only question left to ask is, what will you graph first?